Ladies and gentlemen of the class of 17, use flat screens. If I could offer you only one tip for the future, flat screens would be it. The benefits of flat screens have been proved in Hollywood, whereas the rest of my advice has no basis more reliable than my own meandering experience. I will dispense this advice now. Enjoy the confidence and optimism of greenfield projects. Oh, never mind. You'll not appreciate the confidence and optimism of greenfield till things start going wrong. But trust me, when you finally ship, you'll look back at the code you wrote and recall in a way you can't grasp now how simple everything seemed and how productive you really were. Your code is not as bad as you imagine. Don't worry about changing database providers, or worry, but know that every company who used an ORM in case they needed to switch databases never actually did it. The real problems in your projects are the dependencies you can't control. The engineer who unexpectedly leaves your team at 4 p.m. on some idle Tuesday. Learn one thing every day that scares you. Optimize. Don't reformat other people's code bases. Don't put up with people who reformat yours. Rebase. Don't get obsessed with frameworks. Sometimes they help, sometimes they hurt. It's the user experience that matters, and the user doesn't care how you created it. Remember the retweets you receive, forget the flame bait. If you succeed in doing this, tell me how. Keep your old hard drives. Throw away your old network cards. Refactor. Don't feel guilty if you don't understand F#. Some of the most productive junior developers I've worked with didn't know F#. Some of the best systems architects I know still don't. Write plenty of tests. Be kind to your keys. You'll miss them when they're gone. Maybe you have a degree, maybe you don't. Maybe you have an open source project, maybe you don't. Maybe you wrote code that flew on the space shuttle. Maybe you worked on Microsoft SharePoint. Whatever you do, keep improving, and don't worry where your next gig's coming from. There's a big world out there, and they're always gonna need good developers. Look after your brain. Don't burn out, never be scared to take a break. It is the most powerful computer you will ever own. Launch. Even if you have no users but your own QA team. Have a plan, even if you choose not to follow it. Do not read the comments on YouTube, they will only make you feel angry. Cache your package dependencies. You never know when they'll be gone for good. Read your log files. They're your best source of information and the first place you'll notice if something's starting to go wrong. Understand that languages come and go, and it's the underlying patterns that really matter. Work hard to fill the gaps in your knowledge, because the wiser you get, the more you'll regret the things you didn't know when you were young. Code in 8.6 assembler once, but stop before it makes you smug. Code in Visual Basic once, but stop before it makes you stupid. Read. Accept certain inalienable truths. Your code has bugs, you will miss your deadlines, and you too might end up in management. And when you do, you'll fantasize that back when you were a developer, code was bug-free, deadlines were met, and developers tuned their database indexes. Tune your database indexes. Don't deploy your code without testing it. Maybe you have a QA team, maybe you have integration tests. You never know when either one might miss something. Don't mess too much with your user interface, or by the time you ship, it will look like a karaoke booth. Be grateful for open source, but be careful whose code you run. Sharing code is noble, but there's more to it than taking bits of your project's folder, putting a README file on them, and hoping if you upload it to GitHub, someone else will come along and fix all your problems. but trust me, on the flat screens.
Good afternoon, Sydney. Are you all having an enlightening and educational conference? Yeah. Are you enjoying yourselves? Yeah. Are you coming to PubConf? Yeah. Good. All right. The author Douglas Adams once came up with a set of rules that describe the way human beings react to the technology around them in the world. He said, anything that is in the world when you're born is normal. It's just a natural part of the way the world works. Anything invented between when you're 15 and 35 is new and revolutionary, and you can probably get a career in it. Anything invented after you're 35 is against the natural order of things. Now, this is me. I was born in 1978. Just too late to see Star Wars the first time around. The World Wide Web, I was born into a world where ARPANET already existed, where computers already existed, where we had color TV and, the idea of computer networks and things. But the internet, as we sort of recognize it now, didn't really exist yet. Things invented, the web was kind of invented when I was around 15 years old. And I did go on to have quite a good career in it. I started as a webmaster, I learned HTML, I did, all these kinds of things. The things that were invented after I turned 35 and are therefore unnatural and against the order of things are the Apple Watch, fidget spinners, and something called dabbing, which I still don't know what that is. But, the point that Douglas Adams is making there is that our experience of technology is incredibly subjective. So much of it has to do with at what point do we first encounter these devices and systems and ideas that go on to change the world around us, And it's easy to forget that the things that are all around us every day, these amazing pieces of kit that we all take for granted, that just work, Another thing Douglas Adams, he said, technology is stuff that doesn't work yet. When it works, it's just stuff, Like chairs don't fail anymore because we don't think of chairs as being technology. But the point he's making, all these kinds of things that we take for granted every day, all of them started out as hacks and prototypes and ideas and things that were held together with string and glue and code and gaffer tape and technical debt. And eventually they mature. And if your first experience here is the column on the left, you probably still think of all these things as a pretty controversial idea. And if your first experience is the things on the right, well, yeah, of course we live in a world with smartphones and electric cars. Why would we not, Imagine that. And it's easy to think that there is some sort of Darwinian survival of the fittest, that we have all these prototypes and all these ideas and all these solutions to problems like smartphones and digital communication, and the best solution is going to win. But that is absolutely not true. And what I'm going to talk about today, one of the ideas behind this talk, I want to look at the points in the history of the web where something just kind of happened for a dumb reason. And I'm going to tell you a story about what might have happened if it had gone ever so slightly differently. So, let's go back to the beginning. In the beginning, IBM created the mainframe, and it was good. A computer so powerful that Thomas J. Watson, who the Watson AI system is now named after, thought the world might one day need as many as 5 of these computers. During the second half of the 20th century, scientists and engineers took all of this computing and information theory. We went from valves to transistors to integrated circuits. We went from machine code to assembler to interpreted and compiled languages. These computers made their way out of laboratories and companies and universities and started making their way into people's homes. And towards the end of the 1970s, IBM dominated computing in a way that, you can't quite, you think of the biggest companies in the world today, Google or Alphabet and Apple and Amazon. all of them, you can probably think of someone, say, Apple are dominant, but other people are still selling laptops. Other people are still selling smartphones. IBM basically owned the world in the late 1970s when it came to information technology. And they realized that there might be an opportunity here to sell people a computer that you could fit in a car and take home and actually have in your house. Turns out Tom Watson was wrong. Maybe they could sell more than 5. And there was an opportunity here. Now, IBM in the 70s was a juggernaut. You couldn't steer it. It was this massive enterprise that was incapable of doing anything quickly because it would take 6 weeks just to approve the font for the purchase orders. And so they came up with an interesting idea. They put together a team to create the first personal computer, the PC. They were frightened of getting left behind, and they made a radical decision. They said, we're not going to manufacture this thing. We, IBM, are going to buy parts off the shelf that are being made in factories all over the world. We'll pick stuff up where we can. We need a motherboard, get one of those. Processor, Intel have those. Serial bus, yeah, get some of those out of Taiwan or China or Singapore or wherever the stuff is being manufactured. And they needed an operating system. And so they went shopping. They went to see the best software company in the world when it came to building operating systems for home personal computers. And who was that in 1981? We'll find out a little later. Now then, while IBM are working out how to put computers in your house, the Advanced Research Projects Agency, ARPA, is coming up with this crazy idea to connect computers together. And they had this good idea, like if we could connect 4 computers together so that if one of them got wiped out by some kind of Cold War military attack, the others still work, that might be a good idea. Let's start engineering here for resilience. And around the same time as IBM was launching the PC, ARPA published a specification for an internetworking protocol. The standard, which became known as IPv4, was published around 1981. This is actually a map of the internet from 1973 of every single device that was connected to the ARPANET before it became the internet, drawn by hand by a draftsperson with a pen and paper. That's every single device and what they're running, This was published in 1981. January 1st, 1983 became known as Flag Day. That was the day they said, from now on, everything connected to our network must run TCP/IP. That's it. 1982, they ratified a standard called SMTP, the Simple Mail Transfer Protocol. We suddenly had this system where all the computers in the world could talk to each other, and a system where the people using those computers could send mail to one another. Now, the internet started to grow. And the problem with systems that are growing is you need a way of keeping track of them. Now, there are only 2 really hard problems in computer science. One of them is cache invalidation, the other one is naming things. So let's talk about DNS. Because before DNS was invented, if you set up a new server and you put it on the internet, you would plug it in, and then you would phone Jake, and you would say, Jake, I've got a new computer. Can you add it to the hosts file, please? This was the hosts file. It was a file that lived at the Network Information Center at Stanford. And when one of your team was going there for a meeting, you'd say, oh, can you grab a copy of the hosts file and bring it back? Or you'd FTP it overnight when the phone calls were cheap, or you'd get them to send you a copy on a tape or something. But this was how organizations managed their list of hosts that were connected to the internet with this one file. If you wanted to add a machine to the hosts file on a public holiday, you couldn't, because the people who had permission to edit the file were all off celebrating with their families. You couldn't add machines at night or on the weekend or at Thanksgiving or at Christmas. And it kind of worked for a while, but it was obvious that this internet thing was likely to start growing a little bit, and maybe we needed a better system. So enter this guy, Paul Mokapetris. He's from the University of Southern California, which also invented Unix and LSD. So thank you, University of SoCal, for those contributions to society. And they hired him, and they said, look, we need a better solution to this host system. We got these 5 different engineering solutions. Could you look at them all and just pick the best ones and keep everyone happy? Now, I quite like what he did next, because I think it's what I would have done next. He looked at all 5 of these solutions and went, these are all crap. He threw them away. And he designed and invented by himself DNS, a hierarchical database of host names and network addresses, which has the fantastic quality, it has survived pretty much unchanged from his original specification because he designed it to scale with the complexity of the network it was supporting. The more hosts you connect, the more DNS servers you've got, the more you can share the load, the more stuff gets cached, the fewer root-level lookups actually have to happen to make that system work. And that still survives today, supporting hundreds of millions of domains now. So the scene is set. TCP/IP exists, DNS exists, SMTP exists. We've got conventions and protocols. Computer hardware, commodity hardware is cheap. Lots of people have it. And in CERN, on the border of France and Switzerland, this guy, Tim Berners-Lee, web developer, is, he uses this job title. That's the real title that Tim Berners-Lee uses. And I love Scott Hanselman's like, he could have been the web developer. But he's like, no, web developer's fine. He's working at CERN, and he's noticed they have these fantastic computer networks now. But most of his colleagues, who are physicists and mathematicians, if they want to publish their work so someone else can read it, they don't really have a kind of digital equivalent of journals. And he thinks, what if we could come up with a way of publishing material online, on the network? So he writes up a proposal, information management, Tim Berners-Lee, and he sends it to his supervisor, who sends it back with a 3-word comment. Vague, but exciting. Now, it is really easy in hindsight to think, well, obviously, that's the World Wide Web. That's how it was going to end up, this idea of HTML and HTTP and links and all this kind of stuff. I was studying at the University of Southampton in 1997, and one of my professors, actually 2 of my professors there, had worked on a competing submission for hypermedia. Before the World Wide Web was invented, there was this big international hypermedia conference, and one of my professors, he said, I was sat there and I got up and I showed them my system, and then the next guy who got up was this chap called Tim, who had come over from CERN, and I sat there and I thought, yeah, we're not going to get this one. But the system that the Southampton team had was a thing called Microcosm. And this is actually a screenshot of a running Microcosm system running on Windows 3.1. And Microcosm didn't use embedded hypermedia because their philosophy is we don't want people to have to edit their documents because these documents already exist. We don't want to have to rewrite everything. What we'll do is we'll invent a network server that can maintain a database of links independently of the material that's being linked. So you can put your text files and your rich text files and your WordPerfect files and whatever on a network file share. And we will run an indexing service over the top of them that doesn't touch the original documents, but it looks for keywords and contexts, and it links things into other things, and it shows you all of the links here in a separate window running alongside your content, so that you're always presenting the original document the way the author intended it to be done, and the hypermedia is being applied by librarians and information analysts. And it's fascinating just to see this now has survived. Microcosm became Multicosm PLC, who now do a very good line doing discovery and big lawsuits where they've got all these documents and files on some company's subpoenaed server. And they use a variation of that tech to this day to go through and index all that material. But this is a completely different philosophy on how online hypermedia might have worked. But
you unlock this door with the key of imagination. Beyond it is another dimension. A dimension of sound. A dimension of sight. A dimension of mind. You're moving into a land of both shadow and substance, of things and ideas. You've just crossed over into the Twilight Zone.
We're at CERN. It's the early 1990s. Tim Berners-Lee is in his office. He's been playing around with something called the mesh. And a couple of other people have also got projects that are related to mesh systems and things, and he's thinking he needs a new name for it. And he has this idea, he thinks, what if I call it the World Wide Web? And he's scribbling www on pieces of paper and ideas and everything. And then something fortuitous happens one day. The network goes down, and he has to tell someone what he's doing over the phone. And he picks the phone up, he calls them out, and he goes, yeah, it's this www. And they say, hang on a second. That acronym is actually longer than the thing it's short for. if this catches on, it might sound a little bit daft. And Tim thinks, that's a good point. So he calls his colleagues in when they're all having tea at 4 o'clock in the afternoon and says, look, I got this thing, and I need some names for it. What do you think? And someone goes, yeah, well, World Wide Web, yeah, I see the problem with that one. What if we call it the International Information Interchange, the III? And someone goes, no, that sounds like pirates. And someone who's just read Neuromancer says, what about the multinational metadata matrix? And they think, oh, yeah, that sounds like it could have potential. They play around with these ideas for a little while. Eventually, he comes up with the Global Repository of Interlinked Documents, the GRID. He's got a name. He needs a protocol. Protocols are always called the something, something, something transfer protocol, file transfer protocol, mail transfer protocol. He's like, I'm slinging hypertext here, hypertext transfer protocol. And he looks around and he thinks, well, there's a couple of basic operations for publishing and updating documents. And he looks at structured query language, SQL, and he thinks, we can borrow some ideas from that. We'll have a verb in our thing, select, means select that document from that server, bring it back to me. Create, I want to publish something on the grid. Update, I made a mistake. Please take that document and update it with these changes. Delete means take that down. The lawyers have just got in touch, and that's not supposed to be there. And someone walks into his office and goes, maybe it's just possible it might end up supporting more than that. What if we add submit as well, so you can send instructions to a remote system, get it to do something for you? Now, one of the things that Tim really likes about these is they're all the same length. So when you view your web log file, your grid log files in a fixed width font, it all lines up nicely. Wouldn't that sound like a nice engineering solution? The next thing they need, we've got a protocol, we've got a name, we've got all these resources, these grid pages that are going to be out there on the internet somewhere. We need a way of identifying the ones we're looking at, the thing we want to select. He plays around for a little while. He comes up with something that becomes the standard unique resource finder. The word surf looks like it might catch on. People might talk about surfing the grid. That could be interesting. And he comes up with a draft for this. And the first draft of it is http://user@parse@grid.domain.com:/path?path?query#fragment. And someone goes, why are you putting username and password credentials in plain text on something that's going to be part of the user interface? And he says, good point, we shouldn't support that. That would be stupid. http://grid.domain.com:/port-path-query-fragment. And he's thinking, we could probably make this a little bit simpler. Let's, query and fragment are normally going to be optional. So we'll delegate those to stuff that's just being used for search and indexing and stuff. And then he comes up with, we'll have default documents, so we can just go grid.domain.com, and that'll host a default document. And then he thinks, what is this // thing? Is that, he got it from Unix file systems. But this isn't a file system. This is a completely new thing. Let's get rid of it. And then someone points out that if you put hosts on your network whose name is a number, that could be ambiguous between the host name and the port number. This is a problem. They think, what could we do about this? He changes it. He goes with http bang grid.domain.com ! That separates the protocol from the resource, from the host. And then he has a good idea. He thinks, what if we just establish a convention that if there is a host on your network which has the same host name as the protocol you're using, we can leave that part out completely. Grid bang domain.com, that's it. That is the fully qualified grid address of the default document on your server. Bang, nailed it. And one of his team says to him, Tim, don't you think gridbang.cern.org sounds a bit silly? And he says, not as silly as http://www.cern.org. And then he says, yeah, you're right, good point. It's a good thing we fixed that one, hey. Next up, we need a way of presenting these documents, a way of presenting this hypermedia. And he starts out with a proposal. He's looking at a thing called the Standard Generalized Markup Language, which has existed since the early 1980s in industrial typesetting, that kind of thing. And he thinks we could use a simplified version of that. So he comes up with this HTML 0.1 draft. He sends it around to some of his colleagues. Now, Tim works at CERN. CERN is a physics laboratory. Most of his colleagues are scientists, mathematicians, physicists. They publish equations, which have lots of less than this and greater than that. And they come back and they're like, please don't use angle brackets. Like literally every document we've got will break the second we try and publish it on your grid system because we use those angle brackets for something else. And he thinks that's an interesting point. So he takes a corpus of all the text files that are already available on FTP servers and online on various network shares, and he does a frequency analysis to find the least common ASCII character in all the publications at CERN. Anyone want to hazard a guess at what it might be? It's the tilde. It's ASCII code D7, is the least frequently used character in the basic ASCII set. He thinks, all right, that's it. The tilde will be the markup signifier character in my new language. Plays around with it. OK, first rule, let's take a double line break. That's a paragraph break. That means the vast majority of text files are already valid grid documents, because people have been writing in plain text, they don't use tildes very often, and they've been using return to indicate a paragraph break. Let's just preserve that behavior. So a lot of these documents we can publish online without having to edit them at all. Comes up with some ideas around markup. There we go, that's a heading. That's a paragraph. It's got some bold text in it. Comes up with something a little more elaborate. Eventually, he circulates his draft, HTML version 0.2. He's got this colon, key value syntax for denoting attributes. So this is an HTML document. The language is English. He realizes that most of these things are going to have some metadata, which is for machines to read and present elsewhere in the user interface. And it's going to have a document part, which is for people to read, which gets presented in the main user interface. There are headings. There's paragraphs. He invents a way of linking, which he uses link for, because it creates links. And someone says, Tim, why don't we call it anchor? And he's like, what is anchor? Why would you call it that? That makes no sense. He creates a way of embedding images. He publishes this specification online in about February of 1992, and the world goes crazy. Everybody gets grid fever. Suddenly, companies all over the world are thinking, we need to get some of that. Do we know anyone who can do that? Is there anyone? People start taking like a 2-day course and setting themselves up as grid masters and running very, very successful businesses because they know how to print a business card, and they know that no one else knows that they don't know what they're doing because this is all so new and exciting, which incidentally is how I got my first job. But it finally peaks with the launch of the first graphical open source grid browser, a thing called NCSA Mosaic from the National Center for Supercomputing Applications based at the University of Illinois. This supports all of the existing network things. It supports NNTP, so you can read Usenet with it. It supports Gopher, it supports FTP, but it also supports this new grid protocol. It can browse grid pages, it can display images, it can link to other things, and the world stands up and takes notice. Now, you remember I said at the beginning that in the early 1980s, IBM had this personal computer, and they were shopping for an operating system to run on it. So they went to the best in the business, the absolute finest group of engineers who were working on personal computer operating systems anywhere. Digital Research. And Gary Kildall, the head of digital research, had a knock at the door one day. It's IBM going, we want to buy your operating system. They sit down, they have a bit of a chat. Now, what Gary Kildall has realized, and IBM haven't, is that if your flagship computer is made out of off-the-shelf parts that you bought from China and Singapore and Taiwan, you don't actually own anything. The key to running applications is no longer the hardware, because anybody can buy that. The key to running applications is going to be the operating system. And so Kildall thinks for a minute, and he goes, all right, I will sell you a license to use my CPM, the control program for microcomputers. I'll license that to IBM. You can copy and ship as many copies of these as you want, and I'll give you a 50% discount if I can have a license to do the same thing myself, and I can keep selling it. The deal is done. IBM shipped the personal computer with CPM 8.6. Gary Kildall and Digital Research continued to develop it. When IBM launched their first 16-bit computer, the PC-80 in 1984, Digital Research are ready. They got a thing called MPM 8.6. It's the multitasking program for microcomputers. It's a game changer. It's the first truly multitasking operating system. Doesn't have any legacy constraints. There's no 640K memory limit imposed by the 8086 processors. It is a protected mode 16-bit operating system, runs on the 286 processor, and pushes the thing to the limit. But what really kicks them into the big league is that it runs on any compatible hardware. There's companies all over the world now popping up with these beige clones of IBM boxes. Buy one of those, put a Digital Research operating system on it. By the time IBM realized their mistake, it is too late. Digital Research is rapidly becoming the biggest company in the world. Now, out in California, there's competition. There's Apple, who have had a pretty good run since the Apple II computer was put together in the late 70s. They've done the Lisa, they've done the first Macintosh. Everything is not healthy at Apple headquarters. There's a lot of strife, there's a lot of conflict, and eventually in 1987, there's a hostile takeover. The shareholders take Steve Jobs, the visionary genius who founded Apple Computer, and they kick him out on his ass. And he moves across the street because he wants to rub in their faces what he's going to do next, and he starts a new company, Next. They're done with beige. Everything they do from now on is going to be black. They come up with a thing called the Next Station. It is a black cube about 8 inches on a side. Nobody's really ever seen anything like it. These IBM clones are going for $800-900. The Next Station retails for $10,000. It is aimed at cinema production. It's aimed at medical research. It's aimed at really, really high-power software development. A couple of these boxes end up in CERN. Tim Berners-Lee is using one of these to develop his prototype grid applications. The first grid browser, which being Next is called gridbrowser.application, actually was built and run on one of these Next systems. Meanwhile, digital research merged with the second largest software company in the world, the WordPerfect Corporation. The United States Department of Justice flaps around for about 18 months going, something must be done. We can't have a company that powerful. Won't somebody think of the children? But they can't actually come up with a way to block it, and so Perfect Digital is born. They're planning something big. They have the best Office suite in the world. They have the best word processor in the world. They have the world's leading flagship operating system. They're thinking, we need a grid browser. We need a way of browsing the grid from our platform. So they go and they have a chat with these guys. Anyone recognize these two blue-shirted individuals? So the chap on the left is Jim Clark. Jim Clark was the founder of Silicon Graphics. Spent the 1980s building these incredibly high-powered 3D graphics workstations. The chap on the right is Marc Andreessen. Marc Andreessen has been working at NCSA. He is one of the founders of Mosaic. He's one of the engineers who worked on the original Mosaic grid browser. And they have both, for various reasons, they've both quit their jobs, and they're fishing around for something to do next. And they're thinking, maybe we could start a browser. Might be a good idea. We could build something, Mosaic was all right. Let's kill it. Let's build a Mosaic killer. We can call it Mozilla. How about that for a name? But then they get a phone call. The Nintendo Corporation ring them up and say, look, we got this new Nintendo 64 console we're working on. And we think it would be really neat if you could plug this into the phone jack on the wall and you could play like Mario Kart and Donkey Kong against your friends around the world. And Jim Clark and Marc Andreessen, they think long and hard about this, and eventually they think, this actually sounds like a pretty good idea. The Mozilla project never happens. They move to Seattle. They start working for Nintendo. And who do they meet walking around the office in their first week there? But these two illustrious gentlemen, the two Johns, John Carmack and John Romero. A couple of years previously, over the course of a very, very long weekend fueled by a lot of pizza and caffeine, the Johns, Carmack, and Romero had ported Super Mario Bros. 3 to NPM 8.6. And they put it on a disk and they sent a copy to Nintendo. And they said, check this out. We managed to get side-scrolling out of a 286 CPU. They said nobody could do that. And Nintendo went, this is brilliant. Come and work for us. And they did. Off in Seattle, Jim Clark, Silicon Graphics, Marc Andreessen from Mosaic, John Carmack, probably the finest graphics programmer of any generation, John Romero, who's quite good at level design and having good hair. The four of them sequestered away with Nintendo bankrolling the whole project. Who knows what they're going to come up with? In the meantime, the team at Perfect Digital are back to the drawing board. They have the Gem 3 desktop, their 286 visual operating system. They have a whole bunch of things. They need a grid browser. So they go to the next name on their list. They go knocking, and they discover that the law school at Cornell University, it's a guy called Thomas Bruce. He's a librarian. He runs the library, and he has written a grid browser for NPM and GEM systems. Now, the Perfect Digital Corporation has fantastic relationships with the legal community because WordPerfect is the de facto word processor for every legal firm in the United States. So they very rapidly hammer out a deal. They acquire the Cello source code, they rebrand it, they optimize a couple of the libraries, they add a couple of features, They come out with GridPerfect. They got WordPerfect, they got LetterPerfect, they got NotePerfect, bang, GridPerfect. There it is, their grid browser. And they include something which goes on to change the face of distributed computing. They extend it, as well as the GRID, Global Repository of Interlinked Documents Protocol, they come up with something called SAFE, Secure Application Frame Encryption. For the first time, your grid client can talk to a grid server, and no one else can sniff in on what you're doing. No one can see what you're doing. Suddenly, this submit verb that they put in the original protocol takes off, because people can do all kinds of things with it. It's not just get me a document, update that document, delete that document. They've included WordPerfect in their grid browser, so anybody who can read the grid can write the grid. They have publishing capability baked in from day one. So anybody who acquires a copy of this thing, they have full-blown WYSIWYG authoring tools going along with it. But it isn't long before people start thinking, having to do everything in terms of static documents here is proving really, really restrictive. Do you think there's some way, could we find like a programming language we could embed in the grid client and on our grid servers so we could actually start delivering rich applications and behavior on this thing? Now, in the mid-1990s, if you are going to embed a programming language in a piece of business software, there is only one choice. There is an obvious contender for this, and that contender is Lisp. Half a century old, it still has a perfect, timeless air about it. A few coders from each new generation rediscovering the Lisp arts. Your father's parentheses, elegant weapons for a more civilized age. Paul Graham is running a startup, a company called viaweb. And what viaweb have realized quite early on is that Lisp is a fantastically good language for building grid servers. The grid protocols are stateless, and Lisp natively supports a concept called continuation parsing. It's a way of capturing execution halfway through some chain of processes, capturing it, snapshotting it, and then resuming it at a later date in a way that you don't need to constantly be allocating state and shared memory and all kinds of overheads and resources and things. Lisp is the obvious choice. Now, around this time, Sun Microsystems, who have been happily turning out Solaris boxes, they've invented a language as well. They've come up with a thing called Java, which is a run everywhere, blah, 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 object-oriented, whatever. And they're pushing this thing hard. They want everyone to be using Java for everything there ever is. And they come knocking. They go and see Perfect Digital, and they say, hey, you know, we'd love you guys to get on board with this Java thing we're doing. And Perfect Digital are like, actually, we've got this language already. And they say, well, maybe you could rename it? What are you calling it at the moment? And they say, we're going to call it HyperLisp. And they're like, could you call it Java Lisp? Or Lava Script, or something Java-y. So they call Paul Graham in for a meeting, and over the course of a long afternoon, he explains his philosophy on programming language design. He tells them about the history of Lisp. He tells them about symbol types. He goes through something that he would later publish online. It's called the Blub paradox, about how all programming languages are not created equal. By the end of the afternoon, Java is basically dead. HyperLisp has won out. The thing that clinches it is when he points out that every piece of Java HyperLisp, every piece of HyperLisp program code is also an expression, and every expression is also a data structure. The language is completely mutable. You will never need to serialize or deserialize anything, because you can literally take a program that is half executed, turn it into a data structure, pipe it over the wire to a client that will basically rehydrate it and just keep running it where it left off. It gives you this fantastically powerful, expressive model for running distributed client-server applications. He turns to the financiers and the bean counters. He says, look, this basically means everyone who starts using your application is effectively donating their computer to you so you can run code on that, so you don't need to invest in so much infrastructure. It's like DNS. It scales with the number of people who are trying to use your solution. That is it. Java is out. The future of client-server grid programming belongs to HyperLisp. I want to see what it looks like? Sure you do. So we have HTML, which by this point is on 4.01 because 4.0 had spelling mistakes in the specification. You can embed blocks of HyperLisp code directly into your code. The simplest possible thing you can do is you can say, all right, we're going to, now Lisp reads backwards because it uses a prefix notation. So we're going to bind, and we're going to bind the load event of the document. I'm not going to say document object because this is Lisp, and it's cleverer than that. We are going to bind the load event of the document to a lambda. This is a callback. And we're going to say when it happens, pass the element that triggered it and the event that happened, and run some code. And that code is just going to say alert, hello world. There you go, hello world in Hyperlisp. Let's look at a slightly more sophisticated example now. So now we have a form on our page, and we're going to bind the submit event for that to a lambda. Now, reading it from the back, we've got this grid submit method that you can see in here. And what that's going to do is it's going to use the network code baked into it and send a callback back to the server and get some response back from that. And when it receives the response from that, because this whole thing is completely asynchronous by design, because why would it not be, it will set the value of the span to whatever came back from the server. And then down here, we got a little bit of kind of boilerplate markup syntax. And so this is a distributed client server, what in a parallel universe, they'd take 10 years to invent, and then they'd call it Ajax, and it would be horrible. This comes out of the box. This is free. Because we have symbol types in Lisp, we can map the elements and the sort of fundamental runtime of the browser directly onto symbols so they don't need namespacing or qualification. We can have hyphens in our variable names because all of our arithmetic operators use postfix notation. So this convention around styling, which is growing up about spaces versus camel case versus underscores, hyphens is the thing that everybody settles on. That just works. The Lambda callbacks built in give us asynchronous client-server communication out of the box. It is a beautifully simple, powerful programming model. We're just beginning to explore the potential of it when there is trumpets and fanfare and Perfect Digital announce Gem 95. Their most powerful desktop operating system ever. They get the Beatles back together for the launch party. They're using the Grid browser is baked into this operating system from the ground up. They're shipping a free version of WordPerfect with no printer support that will let you write and author documents and put them on the Grid. They have this massive party. The Beatles do Get Back because they're using this back button from the browser in all of their marketing literature. And everybody loves it. The future is bright. The future is fantastic unless you are working for Apple, who have kicked Steve Jobs out and are now kind of wishing maybe they hadn't because things have gone from bad to really bad to worse to really worse. And they are floundering around trying to work out what they can do. They need a new approach. They need a new operating system. They need a new brand. They basically need to overhaul everything that they are doing. And Jill Amelio, who is the CEO of Apple at the time, he goes into a board meeting one day and he says, you know, maybe we could try and buy Next and get Steve Jobs to come back. They laugh him out of the room. This is the dumbest idea, and there is no way Steve Jobs is ever going back to Apple after the way they kicked him across the street. But he's not the only visionary engineer who's left Apple during their tenure there. There's a startup, B Incorporated. B have a thing called the BIOS. It is a completely brand new, ground-up high-performance operating system. It has dedicated threading support for playing streaming media, doing real-time communication, audio processing, all these kinds of things. And what B have realized is their operating system is fantastic, but the boxes, the physical computers they were building to run it on, those are proving really difficult to pin down. So they have pivoted. They've changed their strategy. They are going to try and find hardware. And their first step, because both of the engineers behind it have an Apple background, is to port BIOS onto Apple hardware. They set up a meeting. They go and see the Apple people, and they say, we've got this brilliant high-performance, multi-threaded, real mode, protected mode operating system. Would you be interested in, acquiring it? And Apple think this is brilliant. This is exactly the thing that they've been looking for. They jump all in. They love the styling. They love the branding. They love it so much that the next line of Apple computers that come out, which are instantly dubbed banana boxes by the press, these things are brilliant. Up till now, computers have been gray and beige. Suddenly, they can make them in yellow. No one had ever thought of doing this before. Imagine a computer that wasn't beige. People want this in their house. It's beautiful. It's running this amazing new BIOS operating system. The one thing they don't have is a Grid browser. So they make a couple of phone calls, and they ring the cello people, and they're like, we already did the deal with Perfect Digital. You missed that one. And they ring NCSA, and NCSA say, well, Mosaic's kind of open source and limping along, but it's not really doing very much. And then out of the blue, they phoned the Norwegian telephone company, Telenor. And Telenor say, you know, this is funny. We have a grid browser we've been working on here. It's a thing we call Opera. And we're not quite sure what to do with it. So the BIOS people and the Apple people and the Norwegian telephone company make a deal, and they acquire Opera, the source code for that, the Presto rendering engine, the network stack that runs it. They rename it B-Link to go with B-boxes and BIOS, and of course it instantly gets renamed to Blink by autocorrect. It supports all the grid protocols: create, update, delete, select, submit. It's got a WYSIWYG editor. Suddenly, you know, there is a first-class competitor again to the juggernaut, which is Perfect Digital running on these beige Office clones. Now, people all over the world have got these systems, and they are writing and posting grid pages left, right, and center. Everyone is getting Dialup, and everyone is getting 5 megabytes of grid space free when they do this, because you can publish a lot of stuff in 5 megabytes, because we never invented those massive JavaScript frameworks in this universe. And it's becoming very, very difficult to find the good stuff, because people are just putting crap online because they think if they get users, maybe later they can work out how to make money out of all of that traffic. And the big unsolved problem in grid computing has become, how do we find content? How do we search for the things that we want to look at? Now, at Stanford, there's a couple of PhD students, Sergey Page and Larry Brin, and they're working out of a garage on an algorithm they call BackRub. And they call it BackRub because it uses links back to documents to decide how credible they are. If lots of pages on the grid are linking to you, then clearly you're important. And then if you link to somebody, that link means they're probably important as well. It's really, really clever. And you know, they're bouncing this idea around and thinking, this could really go somewhere. What are we going to call it? And Sergey says, you know, my kid was in school the other day, and they were telling him about this number called a Google, which is the biggest number. It's like 10 followed by 1,000,000 zeros or something. Maybe we should call our new search engine that, because BackRub sounds a little bit questionable. And remember, we haven't been invented yet, so no one's going to be able to find us. So they call it Google, and they ask someone to go and register the domain. And of course, what happens is autocorrect happens, and they end up with goggle.com. Now, it's a great idea. You know, the technology works really well. They have this wonderfully minimalist homepage. Everyone else is plastering as much advertising as they can onto their grid portals. Goggle has this really nice stripped-down page, but there is just one problem. They have no idea how they are ever going to make any money out of something that works well, is minimalist, and they are providing for free. And so they start kind of looking around for a business plan. And someone suggests maybe you could run advertising. They don't like that idea at all. And then Larry Page takes a call. It's Steve Jobs. He's working on something big, something secret. He might be interested in acquiring Goggle's PageRank technology. Now, we don't know exactly what took place next. We don't know what was discussed in those meetings. We don't know who paid who for what or how much. But we know what happened after that. Computer journalists, April 1999, everyone is talking about the Millennium Bug. We're all going to get killed on the stroke of midnight by all these nuclear missiles that can't handle 4-digit dates or whatever. There is a break from the Millennium Bug hysteria when all of the computer journalists in Silicon Valley get into work one day, and on their desk they find a hand-delivered black envelope. They open it up, and inside there is a card, black printed card. On the front it just says, "Get ready for the next generation." On the back, Menlo Park Amphitheater, 4th of May, 1999. They immediately think this must be a Star Wars thing. May the 4th be with you. So someone phones Lucasfilm. Lucasfilm say, don't be ridiculous. Why would anyone make a sequel to Star Wars? You know, we are not going to mess with perfection. And the rumor mill starts working overtime. You know, what is it? Why are we going? What is this next generation thing? What are we talking about? On the day, May the 4th comes round, the Menlo Park Amphitheater the auditorium is packed. A little before 9 a.m., hush falls over the audience. Steve Jobs takes the stage. And he talks for a while. He talks about the grid. He talks about digital publishing, about empowering people, about technology, about the social impact of all of the technology. And just as everyone wonders where he's going with this, he reaches behind his podium and he pulls out, what is that a laptop? It's called the Next Book. Nobody's ever seen anything quite like it. It's less than an inch thick. It's machined from a single piece of aluminium. It's anodized, lustrous black. It's got no floppy disk drive. It's got no CD-ROM drive. It's got no serial port. How do you plug your printer in? And they're going, you don't need printers. This is the future, you know. It's got 2 USB ports and a headphone jack. The questions start buzzing through the crowd. How do you connect that to anything? How do I get my games? How do I run SimCity? It doesn't have a floppy disk drive. And that's when he unveils his masterstroke, because throughout the audience, there are plants. About 24 Apple employees reach under their seats, and they pull out their next books. They open the lid, and they are already playing the live video stream of Jobs on stage doing his presentation. Nobody has seen Wi-Fi before. Nobody has seen streaming video before. Nobody's seen a laptop like this before. They forget they're supposed to be journalists. People are elbowing each other in the face and clambering over seats, trying to get a look at this thing. They are so blown away that they completely forget they're supposed to be there writing about this thing, because nobody has ever seen anything like it. It's the fastest, lightest laptop the world has ever seen. 333 megahertz ARM RISC processor. 64 megabytes of RAM, 5 gigs of flash drive space. It's got the next version of the Next Step operating system built into it. It has built-in wireless internet. It ships with a box called the Nextender, a thing about the size of a hardback book. You plug this in your phone jack. It's got a CD-ROM drive in it. It supplies the wireless networking for your house, so you don't need to sit next to a phone jack every time you're doing anything. And, of course, Next Step ships with its own brand new grid browser. We say brand new. It's called Nexus. And the DNA of Nexus goes all the way back to the very first grid browser application developed by Tim Berners-Lee on the Next operating system a decade earlier. It's responsive. It's got the fastest Hyperlisp interpreter anyone's ever seen. It's wired right into the fabric of the new operating system. And the whole thing is seamlessly integrated with Goggle's search technology. You can bring up a window, you can search for what you're looking for. It doesn't matter if it's in your folders, in your backups, in your mail, if it's on the grid somewhere, it will find it for you. Steve Jobs is back with a bang. The next generation has arrived. The Millennium Bug comes and goes. The missiles do not go off. Nobody dies, but we all wake up with one hell of a hangover. And the next generation of computing looks like this. We have Steve Jobs, the Next Corporation, the next book running Nexus, based on Tim Berners-Lee's operating system. We've got the banana boxes running Blink, the browser they got out of the Norwegian telephone company, Telenor. We've got Gem 95 and Perfect Digital going all the way back to cello, invented by a librarian working in a law school. And we've got Sun Microsystems, who for some reason are still hanging around going, we can run NCSA Mosaic, look, it supports Java, which nobody cares. But they've invested heavily in their marketing, and they're going to keep plugging away at it. A couple of years later, the buzz starts. Nintendo are coming up with something big. Now, nobody's heard very much from them since John Carmack and Romero and Jim Clark and Marc Andreessen all went off to Seattle with Nintendo bankrolling whatever they wanted to come up with. They did ship a very successful Super Mario Quake world. But after that, everything goes a bit quiet. December 2002, just in time for Christmas, Nintendo unveiled a platform that they think is going to change the world. And it's just called Reality. It is a massively multiplayer online world. An immersive 3D experience takes the world by storm. It's John Carmack and John Romero's dream of implementing the metaverse, visualized by Neil Stephenson in his books, or the Matrix from William Gibson's Neuromancer books. The graphics code, the visualization, the interface is John Carmack and John Romero. The network code is Marc Andreessen. The 3D graphics engine that powers the whole thing is straight out of the DNA of Silicon Graphics. It is virtual reality brought to life. And it seems hard now to imagine life without it, doesn't it? You know? I mean, can you imagine a world without Blink? Imagine a world without Hyperlisp? Imagine a world without B-boxes, without Nextbooks? It's a bit of a stretch, isn't it? So, how much of that is true? How close did we come? In 1981, IBM went shopping for an operating system. They knocked on Gary Kildall's door, the founder of Digital Research, to buy CP/M to run on the IBM personal computer, and Gary Kildall was out. He had gone flying because it was a nice day. There is a slightly less romantic version of this story where he just didn't like them and told them to piss off. But they gave him first call. He, for whatever reason, did not take it. They went and knocked on the next name on their list, which was this enterprising young man, Mr. William H. Gates III of Micro-Soft, who in our universe, by the way, are building a little Hyperlisp debugging tools out of an office in Seattle. They got about 10, 15 people, nice little operation, friendly people. Could have happened, IBM could probably 1 or 2 meetings away. Microsoft would never have become the company they did, and the IBM PC would have taken over the world running a digital research-based operating system. Tim Berners-Lee, the World Wide Web.
Let me start with one historical question, if I could. Again, we live in the world in part you created the architecture for. If you think back to the start, if you had it to do all over again, would you change anything? What would you have done differently?
It's a good question. And of course, you can never ask what would have happened if you'd have done something differently. There's some simple things. In fact, when I designed the URL, this thing which starts HTTP:// the // was to indicate that we're actually starting at the top, that we're not starting down at the next slash, but the colon in there as well. It turns out people never use the // without the HTTP colon. It turns out really, if you think about it, you don't need the // I could have designed it to not have the // and boy, now people all over people on the radio are calling it // people having to use that finger so much. Think of the amount of of print now that would have been saved if we wouldn't have saved, if I'd just removed the double slash. But there you go. You can't. It seemed like a good idea at the time.
Could have been different. HTML, it's based on SGML. That's where we got the angle brackets from. SGML wasn't the only markup language. LaTeX has been around since, the early 1970s? This is what LaTeX markup syntax uses. Lots of people at CERN knew LaTeX. It could so easily, HTML could have been based on something else. Microsoft had rich text format going back to the late 1980s. HTML could have been based on rich text format. The idea of embedding Lisp as a programming language, viaweb was a real company. Paul Graham and his partners really were building web servers in Lisp in the mid-1990s. They sold viaweb to Yahoo, and that's what made him a millionaire. He went on to found Y Combinator with the revenue he made out of that. Lisp was embedded in all kinds of things. AutoCAD came with an embedded Lisp system. Emacs came with an embedded Lisp system. It was the natural choice of programming language. There's even one version of the story that says, when Netscape approached Brendan Eich, they said, we want you to come and work for us because we want you to put Lisp in the browser. And what ended up being JavaScript was a combination of time pressure and marketing pressure. And if this doesn't look like C, it's going to frighten everybody. John Carmack and John Romero really did port Super Mario 3 to the IBM PC. And they sent a disk to Nintendo. But in our timeline, Nintendo didn't say, that's fantastic, come and work for us. Nintendo said, that is fantastic, and if it ever sees the light of day, we are going to sue you so hard you won't be able to find the crater. Because Nintendo had no interest at all in people being able to pirate their games. That Nintendo cartridge, the physical hardware, was a fantastically effective copy protection mechanism. Marc Andreessen and Jim Clark really did get almost to the point of signing a deal with Nintendo to go and build a gaming network. And if they had, that's what they would have done instead of starting Netscape. Netscape would never have happened. Marc Andreessen wouldn't have ended up barefoot on the cover of Time magazine standing in front of a pile of money, And that was these two really smart people going, what do we want to work on next? That looks kind of fun, that looks kind of fun. Maybe we'll do that one. Nah, we'll do that one. That's how easily it could have happened. Cello was real. Real web browser, ran on Microsoft Windows, written by Thomas Bruce, who was the head librarian at Cornell Law School. It was a real thing. BIOS was a real operating system written by 2 former Apple employees. There were real meetings between the engineers behind BIOS and Jill Amelio prior to Apple managing to acquire Next, getting Steve Jobs to come back. He came out with the iMac, the iPod, the iPhone, Apple's resurgence from a company who were nearly on the brink of death to $1 trillion market cap is almost entirely down to the things they did after Steve Jobs came back into the fold in the 1990s. And Google being up for sale, they tried to sell to Excite for $800,000. Google. They were established. They had the reputation. They had, this formidable thing. They just did not have a business plan. They were trying to sell it to Excite. Anyone remember Excite? Yeah? Anyone use Excite, like in living memory? They were an internet portal. They were a search engine. They could have bought Google for 800 grand, and they passed. They said, no, we don't think your company is going to amount to anything. Google, of course, now basically owns the world, and it's listening to every word we say and indexing it all in case it needs it all later. And the lesson, this talk is designed to be thought-provoking and interesting and kind of cover a little bit of history. But I think if you want to take a lesson away from this, so many of these systems that we use and we rely on every day are not there because somebody worked really, really hard to find the best solution or to make the best decision or to find the best possible team or circumstances to work with. They're there because people found something that was just good enough and they thought about what can we do with it? What's going to be next? Because, we have this thing in our industry, analysis paralysis, where you get overwhelmed with choice. You don't know what to do next. Literally, you could do anything. You have a dozen different platforms to choose from. And, almost all the web development we do now is based on top of a browser that might never have existed if they'd gone to make a games network instead, running a programming language that was bolted together in 10 days by somebody under marketing pressure from Sun Microsystems. Even if you don't get those decisions right, there isn't really a right and wrong. All there is have we got enough to go on and make progress? And as you see in this talk, we could have ended up making a very, very different kind of progress. Maybe we still will. But back here in the real world, enjoy Chrome and Firefox and Safari and Microsoft Edge. But that was the web that never was. Thank you.